Welcome to day 9 of competitive programming challenge. Actually, due to some technical issue, I have lost all the recording that I have recorded for 1 hour. The way I have solved all these three questions and this high frequency question I have solved it off the camera. So I thought I'll just explain how I have solved them. Sorry for that. The whole point is to record the way I am solving the questions, but somehow I lost the recording. I lost all the. You can see the timer is also just ended at 1:16. I could have all recorded again one more time the way I solved, but it's yeah, it's since I have already solved it, it will be more like I'm explaining. So I thought, why not just explain what I have done? So let's start from the question high frequency. So it's not get, it's term high frequency. Okay. So this is the solution I have done. Before entering to the solution, let's just see how the way I have solved it. Chef has an array A of length n. Let f of a denote the maximum frequency of an array element present in the array. If A is 1 2 3 2 2 1, then f of A is 3, since element 2 has the highest frequency equal to 3. If A is this, then f of A is 2, since highest frequency of any element is 2. Chef can perform the following operations at most once. Choose any subsequence S of the array such that every element of S is the same, say x. Then choose an integer y and replace every element in this subsequence with y. So for example, let A is equals to 1 2 2 1 2 2. A few examples of the operations that chef can perform are, so basically he will select the subsequence and he will change them. Now we need to determine the minimum possible value of f of a chef can get by performing the given operations at most once. So let me simplify this. Now that you are given an array, let's take any test case. So we'll take 1 2 1 2 1 2 1 2. Now let's maintain a frequency array. Frequency of 1 is 2 and frequency of 2 is 2, right? Now the maximum frequency of an element is f of a. In a given array, the maximum frequency is f of a. Since highest frequency of any element is 2 in an array, highest frequency of any element is 2. It can be 2 or it cannot be 2. The highest frequency is 2. For example, here it is 3. 2 is repeated twice. Since element 2 has the highest frequency as 3, that is f of a. We need to reduce the f of a. That means this example is unfortunately it's not appropriate to explain it quite well. So let's say take the last test case 1 2 2 1 2 and 2. Now if we apply the frequency array, it will be this. So here if we want to reduce the highest frequency, we'll select 2 numbers. Now if we select these 3 numbers, the highest frequency will be 3. If we select this 3 and we'll change it to 3, now highest frequency has become 3. So we cannot select, if we do this, if we select all the last 2 elements and then if we change them, now the frequency array will be 2 2 and 2. You have seen the highest. Now the highest frequency is just 2. That means, let's take one more example for better understanding. Let's take 1 5 5 5 5 2 2 and 3 3 3. So if you go for the frequency array, 1 is repeating for, okay, let's say 0 is also present, and 0 is repeating for 0 times, 1 is repeating for 1 time, 2 is repeating for 2 times, 3 is repeating for 3 times, 4 is repeating for 0 times, 5 is repeating for 4 times. This is the frequency array. Now to reduce the frequency, we'll need to select the element having frequency 4. Now if we select 3 elements and convert them into any other element, 777, now the frequency will change into 3. Now the highest frequency is 3. So for this input, the highest frequency we can get is 3. And note that we can at most change once. You can be like, we can change these 2 elements now, then change this element, and then change these 2 elements, so that every single element will be different and the minimum highest frequency will be only 1. Now we cannot do that. It is mentioned here that determine the minimum possible value of f of hs can get by performing the given operation at most once. So in coding, it's quite simple. We are taking a vector frequency n plus 1 and initializing it to 0. Actually all this thing we have done in yesterday itself in day 8 video, so I'll provide the day 8 videos link in the description. Then we are calculating the frequency, then we are sorting the frequency, then we are taking the second highest second numbers frequency, because highest frequency will be let's say 4 and the second highest frequency will be 2. Notice that the frequency array size is n plus 1, that's the reason n minus 1 is the second one and n will be the last element. Now we are using sail function. Now the functionality of sail is it will return the nearest the highest integer of a floating value. Like say if the value is 2.5, then sail will return 3. So here the element will be returning highest nearest highest and nearest integer. Okay, we are reducing the last element frequency by 2. If we do so, if we get k is greater than the frequency of n minus 1, the second highest numbers frequency, let's say for 4 highest frequency we change 3 elements and we got 3, and the second highest number frequency is 2. Since 3 is greater than 2, answer will be 3, because in the whole array the highest frequency should be minimum, so which is 3 and which is minimum. If that's not the case, then we'll be just printing the frequency. Actually I forgot to have the timer, so let's check how long it's been. For now it's been 8 minutes. Okay, that's how we have solved this question. Let's close this. Let's go for MEX. It is similar. The concept of MEX is we have seen in yesterday's video itself. Now let's go for the MEX, and in this MEX basically you will be giving, let's open out, it's not in this directory, it's here, autumn MEX, right? Actually even Git also says we have changed this actual files just today. Unfortunately we lost all the explanation and all the way my approach to the question. Anyways, here I am using unordered map. You can use ordered map, you can use general map or unordered map. General map is based on balanced binary trees, so the time complexity, the average time complexity to access an element is order of 1, or sorry, it's order of log n. When you use unordered map, it will be using hash tables, so the average time complexity to access the elements is order of 1. So that's why I'm using unordered map, since these questions are based on TLE. Anyways, first let's see the question. You are given a multiset S of n integers and an integer k. You want to find the maximum value of minimum excluded non-negative integers. By the way, that is the full form of max. M and ex max, which is max of the multiset, given that you are allowed to add at most any k integers to the multiset. Find the maximum value of max that you can obtain. For example, of finding max of a multiset are as follows. Max of a multiset is 0 is 1 and 1 is 0. 0 1 3 is 2. 0 1, okay. Max is like, in this element the minimum non-negative number is actually 0, but 0 is present in the subset, so it cannot be the max. The next minimum number is 1. It is also present here, so it cannot be max. Next small number is 2, which is not present, so that is the max. So they will give the input and output are like, they'll give the number of test cases, we need to read them, and they will give n and k values. Now I have taken a map. First I am reading the numbers. While reading the numbers, actually I need not calculate the maximum also. I have calculated the maximum for this loop, but later I realized that what if the array is like, let's say the array is 2 4 3 6 and size is 3, so I'll take 6 and I'll check numbers less than, okay, size is 3, right? What point to be remembered is, in finding max, any element value whose value is greater, any element in the array whose value is greater than the size of the array will not affect the max. Okay, now 6 will not affect the max, so it doesn't mean, so it doesn't affect the array, so it may be 6 or it may be 0. If it is 0, it will affect, so any number greater than 3 will not affect the max. So number is 0, right? So we'll I thought we'll find the maximum value, which is 6, and then we will run this for loop. If 0 is not found, we'll say 0 is the answer, but it doesn't work in that way. For example, what if they give 0 also, 1 also, 2 also, 3 also, 4 also, 5 also? In this case, and the size of the array is 7. In this case, our max is also 7, right? But our loop will run only for 6, so it should run for 6 plus 1. What if our array size is 8? I'm thinking like, if the array size is, for example here, it is 10 to the power 5, and the element can be 2 into 10 to the power 5, last element. But we cannot have those many consecutive elements, right? So we can actually find the, okay, there is a small update here. We can actually find the maximum and run it maximum plus 1 time. That will be enough. We need not run it those many times. Excuse me, sorry for that. And now let's compile. Okay, anyways, now the trick is, okay, you can find the max, but you are given an variable k, so that you can add those many numbers into the array, so that you can maximize the max. For example, if 0 is not found, then you can add 0 into the max, so that max changes, actually k value will be reduced. Like if the array is 0 1 2 3, okay, sorry, If the array size is changing, then we need to go more than max. I'm so sorry. Actually, yeah, this is correct actually. Because if the array size is changing, we can 10 power 5 they are given, right, k value. So we can add 10 power 5 elements to the array. That means array size will be changed. So I am doing it this many times. For now, let's take an example like so 2, 3 and 5. Now the k is given as 2. Since 0 is not present, we'll add 0. K value will be 1 now. So here 1 is also not present, so we'll add 1. So now k value will be 1. Before it's 1, we'll reduce, so it's now 0. Now 0, 1, 2, 3, 5. We found that 4 is not present. K is also 0, so max is now 4. That's what we are doing in this for loop. In this for loop, we have declared answer. We'll say if m.find, this find function will return to the end of the map if an element is not found. So that's the reason we used find and end. If it is not found and k is also 0, then that is the answer, then we'll break. If element is not found, but here k is not equal to 0, that's the reason it's equivalent. If I write k is not equal and k is not equal to 0 or k is equal to 0, k minus minus will reduce the k value and then we'll print the answer. So this is the code for it. I'll just submit it one more time so that you will believe that this is the right answer. Submission is queued. Currently running test case 3. Yeah, it is submitted and the answer is also correct. It's been 20 minutes long and we'll start we'll start suprem. So autumn suprem. Okay, in this question a permutation of length n is an array. Let's read the question first. A permutation of length n is an array of n integers such that every integer from 1 to n appears in it exactly once. For example, 2, 3, 4, 1 is a permutation of length 4. The subsegment of an array is called good if the subsegment is a permutation of length r minus l plus 1. For example, the array here given the array 3 good subsegments. So they will be giving our 2 integers n and k. We need to print the permutations. So it's basically very simple. We'll find out that if k is equals to 1, then n must be of course 1. If it is not 1, then the permutation is not possible. For example, if we given 1 and 2, is asking k equal to 1 and n equal to 2. In this case, you can see that if we select these two subsets, you'll get it is a permutation of 2, right? 1 and 2, so it's 2. And you are having also a permutation of 1. So here 2 permutations are possible, but he wants only 1. Even if you reverse it, still you'll get 2 permutations possible and you'll get only 1. So only in this case you will print -1. That's it. And in all the rest of the cases, you will print from 1 to n, the k value. The array will be in this order 1 to k value, and from n to k value. Okay. here will not reach the k value, it will be k minus 1. That's what we'll be doing, because we can rewrite this thing as 1, since k is 3, 2 will not reach the k value. We'll now start from 5, 3, 5, 4 and 3. Now you can see here we got one permutation 1 to 2, which is permutation of 2, and this is permutation of 1, and we also got the all array, which is permutation 3. So 5 to 3, this is how you'll get the permutations, and that's what we have done using 2 for loops. That's it. Let me submit even this question, this solution. Currently running test case 3. Yeah, it is also correct answer. It's quite unfortunate that all the procedure, the way I've solved, is lost. I thought I will not upload for today, but I have solved questions right. That to 3 questions today. It would have been great if the procedure is also there. Like me solving 3 questions in a single day is really good. Considering yesterday I have only solved 1 question in 1 hour, and also half of the question, 1.5 question in 1 hour. So now we'll see the large farm, and after this, okay, this is pretty basic question, so I'll just explain the question. They will be giving a size of the array, saying that size of the array is people, and the value in a particular position will say they are father to those many people present in the room. Let's say room has 10 people, and if we select one of the people, he'll be like the array element, let's say 2, 4, 8, 1, 0, 4, and there are 3, 3, 6 people present in the room, and if we select this guy, he'll be like, this value indicates that he is father to one of the person present in this room, and he's saying he's the father to 4 of the people present in this room. So here we need to find out how many of them are saying the truth. Okay, further we will first sort the array 0, 1, 4, 4, okay, I forgot 2, 4 and 4 and 8. Now after sorting, there are in total 6 people. Okay, right? If he is father to 0 people, we'll subtract 0 from it. Now there are 6 people. He is father to 1 person, so we'll remove that person from the room. Now there are only 5 people. He is saying he's father to 2 people present in the room, so we'll remove. Now there are 3 people. Now he's saying he's the father to 4 people present in the room, but it is not possible. There are only 3 people present in the room, so he is lying. This guy is also lying. Even this fellow is also lying. All 3 members of them are right, but we need to print how many people are saying the truth. So here we are subtracting, then we are checking, subtracting, then we are moving the array. So for every element we'll be subtracting, but instead of subtracting, we have done it in reverse form. We'll say there's 0 people in the room, he is father to 1 person, so we'll add 1 here. Okay, let it be 0, it will be 1. He is father to 2 people, so we'll add 2. Now 3 people are in the room. He is father to 4 people, now will be 4. So 3 plus 4 is 7. It cannot be possible. 7 is greater than 6, so he is lying. Now all the people after him will also be lying, because they mentioned the people to They're further to those many people, greater than the people came before in the array. Let me explain it more clearly. Like, all these people are in sorted order, right? So all these people will obviously be saying that they are further to more people than these four persons. So that's what I have done. I have taken two variables. One is total number of people and one is the answer, the truth telling people, which is the answer. So first I'll add the array element. After sorting here, I'll just add them. So then we'll check if that number is greater than the total number of people present in the row. If it is greater, I'll just break and I'll say answer. If it is not greater, I'll add our answer. That means this fellow has a truth. Next, I'll take the next element number and I'll add his answer and I'll check whether it's greater than total people or not. So that's how you'll solve this question, which is also pretty simple. But I have struggled a little bit to find out this logic. There is no fun in directly getting the answer. I really enjoyed going in explaining the procedure I have done, which at first is not correct. Then I found out the mistakes. Then I came to the right logic. That was more fun. I hope next time, by the way, it's the correct answer. I hope next time there will not be any glitches. I'll make sure the recording will not get lost. Anyways, thank you. That is for today. And of course, the code will be